Hello viewers, today we'll see trigonometrical identities, exercise 21a, question 21. It's a continuation of a previous video. So we need to prove LHS is equal to RHS, and it's of form, LHS is of form a plus b whole square. So we can just expand the formula a square plus b square plus 2ab. So that's going to be sine square a plus cosecant square a plus 2 into sine a into cosecant a. We have one more set, that is cos a plus secant a whole square. So that is cos square a plus secant square a plus 2 cos a into secant a. So here, by just remembering few of the identities, we can solve this exercise. So sin a and cosecant a are reciprocal forms, which can be again written as sine square a plus cosecant square a plus 2 sine a, and cosecant a is a reciprocal of sine a, so it can be written as 1 by sine a, and this 2 sine a goes off. Then cos square a plus secant square a plus 2 cos a, and secant a is again here the reciprocal of cos, so it's 1 by cos a, and the 2 cos will go off. Now we know that sine square plus cos square a is 1. So this is one of the Pythagorean identities. And 2 so if you add all the numbers, it sums up to 5 plus cosecant square a can be written as 1 plus cot square a, and secant square can be written as 1 plus tan square a. So if you sum up all the numbers, numerals, that's 7 plus tan square a plus cot square a. Position doesn't matter, we just bring it up to the order of RHS, hence proved. Question 22, prove secant square a into cosecant square a equal to tan square a plus cot square a plus 2. So let's take the LHS, secant square a into cosecant square a. So secant is a reciprocal of cos square, and sine square reciprocal is cosecant square. RHS is tan square plus cot square plus 2. So here we know tan is 2 can be multiplied by tan into 1 by tan, that's 1. Just we are trying to bring it to the format of RHS and LHS are same. So it is of form, if you see now, a plus b whole square, tan a plus cot a whole square, because 1 by tan is also cot. So we are just multiplying and dividing by tan is what we are doing as an additional step. So tan can be written as sin a plus cos a, and cot can be written as cos a by sin a whole square. Now we can take LCM, that's sin square a plus cos square a by cos a sin a or sin a cos a. Order doesn't matter with multiplication and addition, whole square. So cos, you know, sin square plus cos square is 1. So that can be written as cos square a into sin square a, 1 by cos. So that is LHS is equal to RHS, hence proved. Question 3, prove 1 by 1 plus cos a plus 1 minus cos a equal to 2 cosecant square a. So let's take the LHS, 1 minus cos a, we're just doing the LCM, 1 plus cos a divided by, it is a form a plus b and a minus b. So just we can multiply and keep. Now both cos a will go off, so the LHS is, numerator for the LHS is 2 now, And the denominator is a plus b into a minus b. So we know the formula is to a square minus b square. Here the a is 1 and b is cos. So 1 minus cos square a, which can be further written as sine square a plus cos square equal to 1. So sine square a equal to 1 minus cos square a. That's what we're going to replace the denominator with, sine square a. And 1 by sine square is a reciprocal, so it's a cosecant square. Just for the understanding, I'm just adding up one more step. So that is 2 cosecant square a, and that's the RHS, hence proved. Next question 24, again prove 1 minus sine a plus 1 by 1 plus sine a equal to 2 secant square a. So we can just do the LCM, 1 plus sine a plus 1 minus sine a divided by 1 minus sine a into 1 plus sine a. That's again of form a plus b and a minus b. So the numerator part sine a goes off, it's only 2, and in denominator can be rewritten as a square minus b square, wherein a is 1 and b is sine. So 1 minus sine square can be again written as cos square. So 2 by cos square a, and cos square is a 1 by cos a is a reciprocal. Just for your remembrance, I'm showing the identity on the right side. How we are derived at cos square a in the denominator. So 1 by cos square is a reciprocal, which is a secant square a. So that proves the RHS. Question 25, prove cosecant a by cosecant a minus 1 plus cosecant a by cosecant a plus 1 equal to 2 secant square a. So we'll just take the LHS LCM, cosecant square a plus cosecant a plus cosecant square a minus cosecant a. So that's the numerator, and the denominator is again of form a minus b and a plus b. So cosecant square is cosecant a and b is 1. So we can write it as cosecant square a minus 1. And in numerator both the cosecant a goes off. So that's going to be 2 cosecant square a divided by cosecant a minus 1 can be written as cot square, because 1 plus cot square a equal to cosecant square a, which can be rewritten as cosecant square minus 1 is cot. So the denominator is replaced with cot square a. So 2, and cosecant is 1 by sine a. Cot can be written as cos square a by sine square a. So both the sine squares will go off. That's going to be 2 by cos square a, which can be written as 2 secant square, as it's just a reciprocal. That's the RHS, hence proved. Next 26, prove secant a by secant a plus 1 plus secant a by secant a minus 1 equal to 2 cosecant square a. And just by taking LHS LCM, secant square a, directly we can do, or we can add up one more step to add the details. Each step will have actually some quarter marks. So let's detail it out step by step, not to lose any marks. So secant square a minus secant a plus secant square a plus secant a. So both secant will go off. Then secant square minus 1 is tan square. So we know the identity 1 plus tan square equal to secant square. And by rewriting it, the denominator can be replaced with tan square a. So now we have 2 secant square a in the numerator by tan square a. So secant is a reciprocal of cos. So 2 into 1 by cos square a And tan is sine square by cos square. Both the cos squares will go off. That's going to be 2 by sine square A, which is the reciprocal of cosecant. So that's going to be 2 into 1 form actually, which is 2 cosecant square A. And that's the RHS, hence proved. Next 27, 1 plus cos A by 1 minus cos A equal to tan square A by secant A minus 1 whole square. So by just taking the LHS, 1 plus 1 by secant A by 1 minus 1 by secant A. Then take LCM, so secant A plus 1 by secant A by secant A minus 1 by secant A. That both goes off. So it's going to be secant A plus 1 by secant A minus 1, which we need to multiply both the sides by secant A minus 1. It's just 1 you're multiplying actually. So the numerator is of form A plus B and A minus B. So it is A square minus B square. So secant square A minus 1. And denominator is 2 sets of same thing. So secant A minus 1 whole square. And 1 plus tan square is secant square. So tan square equal to secant minus 1. So the numerator can be replaced with tan square A divided by secant A minus 1 whole square. That's the RHS, hence proved. Next 28, cot square A by cosecant A plus 1 whole square equal to 1 minus sin A by 1 plus sin A. So just take the RHS, that's 1 minus sin A by 1 plus sin A. We can just sin A can be written as 1 by cosecant A. And again sin A can be written as 1 by cosecant A. Taking LCM, it becomes cosecant A minus 1 by cosecant A divided by cosecant A plus 1 by cosecant A. Both cosecant A goes off. So it's going to be cosecant A minus 1 by cosecant A plus 1 into cosecant A plus 1 multiplying and dividing by the same number. It's actually 1. It's like 5 by 5 is actually 1. Same way I'm just adding what is needed to get the RHS. So it's of again form A minus B and A plus B the numerator, so which can be written as cosecant square minus 1 by cosecant A plus 1 whole square. So there is a difference between both. Denominator symbols are same, plus 1 plus 1. And 1 plus cot is cosecant we know, so cosecant minus 1 is cot. Numerator can be replaced with cot square A by cosecant square, cosecant A plus 1 whole square. That's the LHS. So hence proved. So next 29, 1 plus sin A by cos A plus cos A by 1 plus sin A equal to 2 secant A. So we can take the LHS, that is 1 plus sin A whole square plus cos square A, LCM this is cos A into 1 plus sin A. It's a form A plus B whole square, so we need to expand the formula A square plus B square plus 2AB. That's going to be 2 into sin A plus cos square A by cos A into 1 plus sin A. Here we know in the numerator sin square plus cos square is 1. So 1 plus 1 plus 2 sin A by cos A into 1 plus sin A. So here if you see 1 plus 1 is 2. So 2 plus 2 sin A by cos A into 1 plus sin A. So 2 is common in the numerator, so bringing 2 out, 1 plus sine A by cos A into 1 plus sine A. So both the numerator and denominator cuts. So that is 2 by cos A, which can be written as 2 secant A, as cos is reciprocal of secant. That's the RHS, hence proved. Next question 30, 1 minus sine by 1 plus sine equal to secant A minus tan A whole square. So we can take the LHS and multiply it by 1 minus sine A and divide it by 1 minus sine A, which is actually just a kind of 1. So the numerator become 1 minus sine A whole square by denominator is A plus B and A minus B, which is equal to A square plus minus B square. And we need to rewrite the denominator as cos square A. As we know, sine square plus cos square is 1. So cos square equal to 1 minus sine square. So that's what we have in denominator now. So 1 minus sine A by cos A. Whole square, we can write the same thing. So 1 by cos A is secant A minus sine by cos is tan whole square. So as per the RHS, we have to just rewrite it. Hence proved. Question 31, cot A minus cosecant A whole square is 1 minus cos plus 1 by cos. So here we'll take the RHS, 1 minus cos by 1 plus cos into 1 minus cos A by 1 minus cos A. That's actually equivalent to 1. So 1 minus cos A whole square by A square minus B square. So that's 1 minus cos square A. So the denominator can be written as sine square A as per the trigonometric identity. Now we can bring the squares out, can make it whole squares. 1 minus cos, that's cosecant A. 1 by sine is cosecant. Cos by sine is cot. You can just put whole square. And that's the LHS. Hence proved. Next 32, cosecant A minus 1 by cosecant A plus 1 is cos A by 1 plus sine whole square. So by taking the LHS and multiplying and dividing by cosecant A plus 1, it's equivalent to 1 actually. So the numerator is of form A minus B and A plus B. So cosecant square A minus 1 and denominator is cosecant A plus 1 whole square. This can be written as cot square in the numerator as per the identity, and we retain the denominator same way. So cot is cos square by sine square, and we know cosecant we need to write as 1 by sine A as it is reciprocal whole square. So cosecant square A by sine square A by 1 plus sine A by sine A as per the LCM whole square for the denominator. So both the sine A and the denominators goes off. So that's going to be cos square A by sine square 1 by 1 plus sine A whole square. So which can be written as cos A by 1 plus sine A whole square. That's the RHS. Hence proved. Next question 33. So we can just take the LHS, tan square A minus tan square B. So sine square by cos square is tan. Sine square B by cos square B. We need to take the LCM sine square A into cos square B minus sine square B into cos square B by cos square A into cos square B. So we can take sine square A. Cos can be written as 1 minus sine square B. Again sine square B. Cos can be written as 1 minus sine square A. Here A and B just have a careful substitutions. So sine square minus sine square A into sine square B minus sine square B plus sine square A and 2 sine square B. So these two minus and plus goes off, and the denominator is same, cos square A into cos square B. So that is the numerator, sine square A minus sine square B by cos square A into cos square B, which is the RHS, hence proved. Next question 34, sine theta minus 2 sine square theta, sine cube theta, that is in the question. Please correct the question, numerator part. So that's sine theta. You can take in common. So since it's a cube, 1 is outside, the remaining 2 we need to add by cos theta, we can take it out. So 2 cos square theta minus 1. So 1 minus 2 sine square theta is same as 2 cos square theta minus 1, which is cos 2 theta. Both are same. So sine by cos is tan theta, and that other cos 2 theta gets right, so RHS. So question 35, we'll take the LHS first. Sin A by 1 plus cos A equal to cosecant A minus cot A is what we need to prove by taking the LHS and multiplying and dividing it by 1 minus cos A, which is just equivalent to 1. So numerator is sin A into 1 minus cos A, and denominator is 1 minus cos square A, which can be written as sin square A. So 1 sin A goes off. 1 by sin we know is cosecant A. Cos by sin we know is cot A. So that's the RHS, hence proved. Next 36. We need to prove cos A by 1 minus sin A equal to secant A plus tan A. Let's take the RHS. Secant A can be written as 1 by cos A plus sin A by cos A. That's tan. So we need to rewrite it as 1 plus sin A by cos A, as the denominator is same, and multiply it by 1 minus sin A by 1 minus sin A, which is equivalent to 1, and the numerator is of form A plus B and A minus B, so 1 minus sin square A by cos A into 1 minus sin A. So numerator becomes cos square A, and one of the cos A will go off from the numerator, so that is cos A by 1 minus sin A, so which is LHS, hence proved. Question 37, sin into tan by 1 minus cos equal to 1 plus secant. So we will just take the LHS, sin into tan by 1 minus cos A, and multiply and divide it by 1 plus cos A, which is equivalent to just 1. So sin A into tan A into 1 plus cos A by, denominator is of form A minus B, A plus B, so it is 1 minus cos square A Sin A, tan A can be written sin A by cos A into 1 plus cos A by 1 minus cos square A can be written as sin square A. So sin A, both the sin A's will go down. So the answer is 1 plus cos A by cos A. And we know 1 by cos A is secant A. Cos A is 1. So it's 1 plus secant A or secant A plus 1. Position doesn't matter. Just deriving at RHS. Hence proved. It can be 1 plus secant A or secant A plus 1. Position doesn't matter in multiplication and addition. Just showing it as. Hope it's clear. Next question 38. RHS is 2. So we have to take the LHS first. That's 1 plus cot is cos by sine and cosecant is 1 by sine into 1 plus sine by cos, that's tan, secant is 1 by cos A. So now we have to take the LCM, so sin A plus cos A minus 1 by sin A into cos A plus sin A plus 1 by cos A. Here if you see sin A plus cos A as A and 1 as B, it is again of form A minus B and A plus B, which is A square minus B square. So sin A plus cos A whole square, that's A square minus 1 by sin A into cos A. So this is of form A plus B whole square. So we need to expand it, sin square A plus cos square A plus 2 sin A cos A minus 1, which is already there in the numerator, by sin A into cos A. And we know the trigonometric identity sin square plus cos square is 1. So 1 and 1 goes off. So that's 2 sin A into cos A by sin A into cos A. So both goes off. The RHS is only 2. Hence proved. Question 39. Prove square root of 1 plus sin A by 1 minus sin A equal to secant A plus tan A. So let's take the LHS 1 plus sin A by 1 minus sin A into 1 plus sin A by 1 plus sin A, which is equivalent to 1. So it's going to be square root of 1 plus sin A whole square in the numerator, and denominator is again A square minus B square. So A is 1 minus sin square A. So that's going to be 1 plus sin A whole square divided by cos square. By removing the square root, it becomes 1 plus sin A by cos A. 1 by cos A can be written as secant A, as it's a reciprocal, and sin by cos can be written as tan A. And that's the RHS, hence proved. Next question 40. Square root of 1 minus cos by 1 plus cos is cosecant A minus cot A. So by taking the LHS again, square root of 1 minus cos A by 1 plus cos A and multiply by 1 minus cos A by 1 minus cos A, which is equivalent to 1. So numerator is 1 minus cos A whole square and denominator A plus B and A minus B, so 1 minus cos square A square root. So it's square root of 1 minus cos A whole square by sine square as per the trigonometric identity. So removing the square root, it becomes 1 minus cos A by sine A. 1 by sine is cosecant, as it's a reciprocal, minus cos by sine is cot. So that's the RHS, hence proved. I believe this is useful. If you find this useful, please do share and subscribe. Thank you.